All right, so to this kind of lesson that we're looking at today is going to mostly be review, but it may have a few things in it that you've not seen before as we get closer to the end of each kind of topic. Okay, so we're going to do a little review of exponent work today. And as we go through this, we're going to talk about vocabulary, talk about things maybe that if it's something you can do on your calculator, something you've got to do by hand, something you've got to do. Mr. Sands? All right. So first of all, let's talk about what is an exponential? What are exponents? What do they look like? What are the pieces of vocabulary called? So, for example, we can talk about 2 to the third power. Now, we know that means to do 2 times 2 times 2, right? Not that we're going to do it that way, but this will help develop the vocabulary. That's what 2 to the third means, right? 3 2's multiplied together. What is the answer to a multiplying problem called? Product. And that's going to be a very important word for us because the answer to an exponential is a product, and we need to know that because sometimes we have to move these things around and work with them, and we need to know what each part's called. Can anybody tell me what the 2 is called over here in the exponential part? Close, but no. Well, people think of it as a constant or coefficient because it stayed constantly 2 over here, right? And people think of it as a coefficient because it's in front of something. But neither one of those is what this is. Let me explain the difference. This is a coefficient. It's something in front of a letter. This is a constant because it doesn't have a letter on it. That's neither one, but I could see why you would think of that as that. This is a base, y'all. The part that's the lower, bigger font, when you type an exponential, that's the bigger font part, is called the base. Because that's what you're going to write out however many times the power tells you to write it out. In terms of this 2 to the third power, that told me that I was going to write 3 2's, right? 2's the base. That's the number that you're repeating. So what's this piece called? Exponent, okay? Would anybody think it's a power? Is the word exponent and power interchangeable? Mm-hmm. Yeah, we think that it is. Notice I say we think it is. Because that's what probably most teachers, when they first introduced this to you and they started talking about it, they would read this like 2 to the third power, and you think the word power refers to the 3. It doesn't, but it seems like that. Actually, 2 to the third, the whole entire thing is a power problem. Both pieces together, written in this format, is a power problem. All right, so let's go into negative powers because this vocabulary works great with positive powers, but you need to know how to deal with negative powers because you may have some. For one thing, well, I'll just take this same problem and put it to the negative third power. Now, we know that 2 times 2 times 2 is 8, right? 2 times 2 is 4, times another 2 is 8. So 2 to the third is 8. So let's see how it relates to it, because we know that that's what it works out to be. Let's see how it relates if there's a negative power. Does anybody remember any rules on how to deal with negative powers? It's a fraction. You see, negative powers can be moved across the division bar and turned into positive powers. For example, I can move it across the division line, and that makes that power problem become an exponent that's positive. But then I don't have anything left on top, so I have to put a 1. So anytime you have a negative power, you're going to get a fractional answer, but it's going to be the same number on the bottom that you would have got if you'd have done it with a positive power. Now, what happens sometimes that's really important to understand about this is after a certain point, your calculator won't be able to math frac it. See, that it could have done. I could have typed 2 to the negative third power, my calculator needed to work. But after a certain point, when that power gets too high, it will not frac it. So being able to move that and get rid of that numerator exponent, I'll get right in a minute. Exponent, by moving it from the numerator to the denominator, is important because if I get too high power, I can't even get my calculator to give me the answer. Another thing you have to know is, what does it mean to have negative in front of a power problem? And how is that different from having the negative inside of the power problem? So what's the difference in those two?
The first one, it thinks that it would still be negative, but if you actually think about it, the negative 4, it's like negative 4 times negative 4 equals positive 6.
Okay, so this one means negative 1 times 4 squared. That's what it means. And you're right, this one means negative 4 times negative 4. If the negative's on the inside, then you have that many negatives. But if the negative's on the outside and there's no parentheses at all, then the negative is not part of the power problem. It's just multiplied to the answer of the power problem. So that's the difference between getting negative 16 and positive 16. And that's why some of you keep missing math problems, because you don't put parentheses when you plug a negative number in. So there is a difference between having a negative in front and having a power problem and having a negative on the inside of a power problem. And then the other thing is, what does it mean to have a zero power? Oh, well, let's talk about that a minute. Let's say I have 4 squared over 4 squared. That means 2 4s, right? These canceled out and these canceled out. What does that make? 1. Why? Because that's 16 divided by 16, right? All right. So how does that relate to this? Well, what do you do in division with powers? You subtract them. What's 2 minus 2? So I could have changed this to the 0 power by subtracting the powers, and then I can see that the answer to that problem has got to be 1, because if I work it out without doing that, I get 1. So if I subtract the powers and say it's to the 0 power, that also has to be 1. Think about it. What in mathematics is so important is knowing that 1 times anything doesn't change the answer, right? So if you don't have any 4s to multiply by it, how could it change the answer? It's still going to be 1. So that's important, because if you see a 0 power, there's not much use in working that, is it? Because 1 times anything drops out. All right. Now, let's get a little bit more in depth with looking at powers that are positive or negative and how to work out the numbers. And I'm doing this without a calculator right now because I want you to see kind of what might happen, but we also might look at it with a calculator as well. All right, so we're going to talk about evaluating. So to evaluate an exponential, it means you're really thinking about a multiplying problem. So for example, suppose I have 2 to the negative 7th power, and I want to put that with 2 to the 3rd power. Well, that means that if I know some rules of exponents, I won't have to work so hard to try to get the calculator to give me the answer to a problem sometimes. Because 7th power is kind of high, although 2 is not a really big base. For example, I could take this problem and change it by moving the 7th power down and make it positive. And that would give me an opportunity not to have a negative power to work with. Then I got a couple other things I can do. I could work each one of these individually to see kind of what they come out. Or I could say, well, if I have 3 2's on the top and I have 7 2's on the bottom, what's going to happen? A few 2's are going to cancel out, right? Think about that. If you have 2 2 2 and you have 2 2 2 2 2 2 and 2, not that I'm going to do it this way every time, but if I have that, some 2's could cancel out, right? So the rule that we learned about division and exponent says to subtract. And that's because you're canceling these out when you subtract. 7 minus 3 leaves me with 4. Where? On the bottom. So I could use that rule about reducing them. And then that way I have got my power down small enough that I can do the math. 2 times 2 is 4, times 2 is 8, times 2 is 16. So the answer is 1 over 16. And I don't need a calculator to help me do that. Now that way it probably would give me the answer. It probably would have gave me the answer if I typed the original problem in. I don't know, let's try it. Type the original problem in and go math frac and don't call out anything, just do it so you can see. Will the calculator give me the answer that I have written on the board is what you're trying to see, because maybe it's because my power was on a base that's kind of a small number. Now, depending on what kind of calculator you have, it also has some limitations, because the 83s don't frac as high fractions as the 84s do. All right, did you get 1/16? So it would have worked that problem from the get-go because the powers weren't on a really high base. But if I increase the base, then it might not work that problem as well. All right, let's look at another one. Suppose I have suppose I have this multiplying problem. Now 4 to the 10th is pretty big, right? So this might be one the calculator wouldn't work from the get-go. So let's look at how can we get it down smaller. What should I do first to clean this problem up using exponent rules? Well, okay, put it in a fraction. What am I going to do about this negative out here? Yeah, it's going to be there. Doesn't have anything to do with this part. That's like saying -1 times something. This negative is not on that 4 to the -2. No more than 2's on an x. They are not together. They're just sitting there. So I keep the negative on top because negative coefficients don't move. But a 2 to the negative, 4 to the -2 comes down and becomes 4 squared. Now what do you do in division with powers? You subtract. And that gives me 8 on top, so now I don't have a bottom anymore. Now, because I don't have it in bottom anymore, that means the answer to this problem is a whole number. And it should give me the answer unless the thing goes into scientific notation sometimes. If you get the power too high, I'll just go into scientific notation. There's nothing you can do about that. So what is 4 to the 8th? Because whatever it is going to be negative. -6 what? 65,536. So it's negative that number. So I could have typed the original problem in. The calculator would have probably gave me the answer, because even though that's a very large number, it's not turning it into scientific notation, because it's not too big for the problem to be worked. All right, let's look at another rule. So I have a multiplication problem here where I have an exponential and I have a fraction with an exponential in it. So let's look at each individual piece, one piece at a time, to see what happens. So what should I do about 5 to the negative 2? All right. We're going to move it down because if there's a 1 under there, it just moves across the division line. What am I going to do about this one? Move it up. That's right. If it's on the bottom, you can move it up, and it becomes to the positive 3 power. What about this negative? No, it doesn't go nowhere. Although I could move it up, and it wouldn't be wrong. But it really doesn't go anywhere because he's really not part of that 5 to the 3rd power. He's just negative 1 sitting in front of it. So now, I've got 1 times something. Don't that make it stay the same? And I've got 5 squared times a negative 1, so that's just going to put a negative 1 in front of 5 squared. So you can multiply across the bottom and kind of put it all into one fraction thought. How many 5s am I going to have left after I divide? Where? 1 on the top. If you only have 5 on the top divided by negative 1, isn't that going to be negative 5? You see, your powers you subtract. That makes it to the 1 power. When you subtract your powers, then you've still got this negative 1 down here because it wasn't in the power problem to divide into it. So that's why in this problem, bringing that negative up, we could have done that. We didn't have to do it, but we could have done it. It would still give the right answer. But it's not because it should go up. It's just because you can put a negative on the positive top or bottom of a fraction. All right, let's look at power to a power problem. Now, I didn't have to make both of these powers negative, but I just thought that might be something we want to look at. So before we even think about rules because they're powers, and negative powers at that, but what is the rule if the power is on the outside is really important. So first you need to give it to everything on the inside, because this is negative 1 to that power, and then you've got a power problem to a power. Now let's talk about negative 1 to this power. If I move it down, it's still going to be 5 negative 1s, right? And what do 5 negatives make? Negative. And whether I move this down and make it like this, so it's to the 5th power, it doesn't matter, because a negative on the bottom and a negative on top is still going to be a negative, because it's to an odd power. Anytime you have negative 1 to an odd power, whether it's on top, bottom, whether this is a positive negative power makes absolutely no difference. It's going to come out negative 1 because it's an odd power. But the real rules about it would be you'd move it down and work it out, and negative 1 into 1 is negative 1. But was that going to be any different than if I work it up here as to the negative 5th power? No, it is not. That part's going to be negative 1. Now, what do you do when you have a parentheses between 2 powers? You multiply. So if I multiply those together, that's going to be a positive 15 power. Now I don't have negative powers on that part to move. You may say, well, wait a minute. Well, okay, let's look at that another way. Could I move this down and make that to the positive 3rd power? Everybody agree? Now, everybody's to a negative power. That means everybody has to move. Because if this 1's to a negative fifth power, it's got to go across the division line. And if this 6 to the third's to a fifth power, it's going to have to go across the division line so that can become a positive. Doesn't that still make positive 15? So don't get rid of your negatives up front. Do the power rule thing first about multiplying the powers. Maybe it won't be negative anymore and you can save all that work. So now I'm going to do 1 times 6 to the 15th power. Well, I know this negative 1 times that's going to be negative, but I don't know what 6 to the 15th power is. In fact, it might not even be a nice number in the first place. That's a really large power at a really large base. It might be scientific notation. I don't know if it... Okay, so let's talk about how do you write an answer that's scientific notation, because you might run across one. Well, first of all, we have to estimate that one, because we can't write the whole number out. We can't see all the digits. Okay, so we estimate it. And scientific notation is usually estimated to 1 decimal place. I don't know why, because you'd think they'd want to write every decimal they could see. But they write it to 1 decimal place because they're just estimating. So what would that round off to if it only had 1 decimal place? You know, like 1.2, 3.5, 4.7? Now, what's after the E? 11. That means times 10 to the 11th power. You can't write E11 on your paper, which is what the calculator gives you. You have to turn it back into what scientific notation looks like, which is times 10 to that power. That's the exponent on the 10. Tells you how many decimal places to move it. If I moved it 11 that way, which you probably don't even see 11 digits after the decimal, do you? Do you see how it's going to have to be an estimate because I don't have 11 digits to move it? So why not just round it off more? And so it comes out negative that.
If the decimal smaller than 0 would be like 10 to the negative power?
Right, it could be to the negative power. And that happens when your base and your exponents are really, really small negative exponents. All right. Another thing that might be good for me to show y'all is what do you do sometimes when you maybe have different types of numbers to put together. Like, for example, what if you have 6 to the negative 2 times 4 to the third? You know, really different stuff. It's not like I can add those powers because it's a multiplying problem, right? Or move it and subtract them. The only reason I could do that earlier, let me go back just real sec quickly. The only reason I could subtract these powers was because they had what? The same base. So in this problem, I don't have the same base, which means I have to just know how to work powers out.
Can you put that one like as a fraction?
Yes, you can. In fact, you can put it underneath the other one, so you can save a little bit of work. You don't have to just move this one down and stick a 1 under it. If you got a negative power, put it up under a positive power. At least that way, you've already got it kind of simplified some. Then 4 to the third power, well, 4 times 4 is 16, and times 4 again is 64. I just happen to know that. But if you didn't, you could type 4 to the third power in the calculator. And 6 squared, we all know, is 36. Anything going to 64 and 36? What? 4. Might be a little bigger. That'd be 16 over 9 if we divide both of them by 4. Right? 16 over 9 doesn't reduce, does it? So you can work if they're on a different basis, but in that case, you can't work power rules. You just got to work out each power problem and try to put it together as a fraction. That's a little different. And then the other thing that I would like to look at is what do you do if you have a power problem that you can't work, like 6 squared, okay? 6 squared, we can work that because we know that means 2 6s, right? Or 4 to the third power, we can work that because we know we can multiply 2 4s and then multiply by another one. But what if we get something that the power itself is not something that you can physically do in your head? Like, now this is where having a calculator comes in very handy, because I don't know what to do if that power problem doesn't have a whole number exponent. There's no way anybody can work that in their head. Well, let me rephrase that. I'm sure there's some genius in the world who probably could. But the average Joe can't because it's not a whole number power. So that's where you want to use your calculator. Now, if you have an 83, it's a disadvantage because you'd have to put this parentheses around that power. But with the 84s, y'all got that little box, right? And whatever's in that little box on the exponent, if you type all of that in there, it knows what to do with it. But when the 83s were designed, they didn't have that little box, and so if you didn't put it in parentheses, it didn't do the math right. But now that most of us have 84s, we've got a much better chance of getting this right because whatever's up there in the exponent has to be in the box. And whatever you get is not going to be a very nice number, is it? So these problems would get rounded to 3 places. Can somebody cut that fan back there on? Because with it being so, like, not hot, not cold outside today, kind of so that yucky weather, it makes the air in here not run. Thank you. Just turn it wide open once you get it plugged in. I forgot somebody unplugged it last period. They were plugging their computer in. All right. So what'd y'all get? 9 what? Yeah, cut it down 1 notch. That's better. All right. So did everybody get something started with a 9? And did you round it off to 3 decimal places? Okay. Let's look at another one. Sometimes students look at things and say, wait a minute, that's a letter. So let's look at it. What if it has a letter? Two to the 3 pi. What do you think you type in your calculator for that? Yeah, exactly. If you do 2 to the caret key and it puts that box up there and put your 3, right above the caret key is a pi key. And so you can press second caret and it'll put that pi in there. You do not want to type 3.14 for that. And the reason is because that has a stored decimal in it. Did everybody get this answer? What's that round off to? Is it going to stay a 1 or is it going to go up to 2? Stay a 1, exactly. So what I'm trying to say here is when you look at the buy button by itself, it's more than 3.14. Does everybody see that? It has more digits. It's more accurate than 3.14. So if you try to type the number 3.14 in that power, instead of using the pi button, you won't get the same answer. Because if you type 2 to the 3 times 3.14, look how far off that is. Because I didn't use all the digits. So you have to use the pi button to do that. And then there's one other thing that we can do with exponent problems and typing it on our calculator and getting these decimal answers. What number am I on?
8.
Thank you. I meant to look before I moved it. Suppose I have e to the negative 3. I'll make this easy. Well, first of all, I wouldn't move it down because I still can't work it. I don't know what e to the third power is. You don't know what e to the third power is. Because that's not a number, is it? Or is it? Whoop. Got an extra digit there. Hold on. Come on. Do it right. Or is it? E is a number. It's called a natural number. It occurs in nature and is a pattern, just like pi occurs on all circles. E is a number. It's 2.718 such and such numbers there. It is found above the divide key. It is also found over here on this LN key. The one on the LN key automatically puts the box up there for the exponent. The one on the divide key doesn't. So you actually would want to use the one on the LN key. If you press second LN, it will put it in there and put the box for you. Then when you type the -3 in there, it will give you the decimal that has moved the power down and made it positive and divided it into 1. Calculator's smart. It knows how to move it and make it all work. So this would round off to 0.050. And no, you can't drop that O. And one of the reasons why you can't drop it is I said the answer has to be a 3 decimal place answer. If you drop the 0, it's only a 2 decimal place answer. So 0.49's got to go up to 0.50. So 0.050 is the answer to that question. So E is a number, just like pi. It's an irrational number. It goes on forever and never repeats. It occurs in nature. It's part of a pattern of numbers that occur when you count things in a pattern. And like a pine cone, and you count all those little pieces that goes around. There's a pattern to how many little pieces will go around a pine cone. Things like that. Sometimes you might have decimals up there. Sometimes you might have fractions up there. It doesn't matter what they put in that power. If the E is your base, then you've got to use your calculator for it because there are no options otherwise. Why don't y'all type those two and round it off and get the answer, and then we'll look at it and see if you're right. So they're quick, they're easy to type in the calculator, as long as you're aware of anything that your calculator might not do correctly. Now, I'll even do this fraction right because as long as it's in the box, right? As long as it's in that little box raised up to a power, it doesn't care if you put parentheses around the fraction. Has everybody got both of these work? Well, here are your answers. How did I get my calculator to only show 3 decimal places? That is a really good question, isn't it? Because I went to mode and told it that. If you change float to 3, then it rounds every answer to 3 decimal places. If you are working a set of questions in which that whole set of questions needs to be to 3 decimal places, wouldn't that be a good thing to do? Then you don't have to know the 5 or more rule. Now, there is a drawback to that. If you're taking a test and one question says round to 3 and the next one doesn't say about rounding, you would have to turn that on and off. Because like SAT, ACT, your final exam in my class, they don't give you a whole set of questions together that ask you to round it to a certain place. They might say, here's one about rounding, and there might not be another one for 5 or 6 questions that ask you to round again. But it is a nice feature if it tells you in the question what to round it to, that you could turn that on and off. Now for mine, if I gave you a set of questions that ask you to do 10 of them rounded to 3 decimal places, then I'd turn it on. If I was just doing one here and there, I'd probably just round it in my head because it's easier. All right. Any questions about evaluating either by hand or with your calculator? And we've also hit a few other things today. We've hit power to a power rule. What do you do in dividing? We've looked at what do you do in multiplying. We've looked at negatives. We've looked at the zero power. So I spent a lot of time talking about evaluating to show what those rules do. But ultimately, more often, the kind of question you're really going to have is not going to be evaluating. It's probably going to be simplifying. You'll be asked to simplify some questions. Simplifying means that you're not going to get a number for the answer most of the time. Most of the time, there's still going to be some letters in there. Let's run through a few examples of some simplifying problems. This would be a very simple simplifying problem because it only has one big term. But what rules am I trying to get you to use with this one big term? What do you do with negative powers? Move to the bottom. What do you do with zero powers? Well, then just throw it away. Because 1 times anything don't change a problem, does it? So if you have a zero power, you just throw it away. Think about it like this. How are you going to write some y's down if you don't have any? Make sense? If you don't have any y's, you can't write anything down. It says y to the 0, which is 0 y's. So if I don't have any, I can't write them. All right. What if I have this problem? 4 times x to the 0, y to the second, z to the negative fourth. The whole entire problem is to the negative 1. What would you start with? Okay, why? It's all to the negative. All right, I could do that. Can somebody give me something else I could do first? Because that's not wrong. I can start that way. Right, I could do something about these negatives here, or I can do something about these negatives out here. Does that make sense? Now, I'm going to tell you, in mathematics, usually you want to fix the inside first, because if you fix the inside first, there'll be less stuff to deal with later. For example, that's gone now. Does that make sense? Why work with the negative 1 on the outside first when I could drop that out and that's gone? Or, what about this negative power right here? What am I going to do with him? I'm going to put him on the bottom, okay? If you do everything on the inside first, then all you got to do is flip it, and that finishes the question. Using what you said about the negative 1 on the outside is going to move everybody. Because if I'd have started with the negative 1 on the outside, everybody would have moved to the bottom. And then I'd had to move some up. Well, doing it this way, I got rid of one term, I moved one, but now this negative 1 on the outside just switches the top and the bottom because everybody's to a negative power. So start with the inside, simplify it as much as possible, then focus on the outside. And that's kind of that order of operations type thing. Don't we always do what's in the parentheses first? Same idea. All right. Now, let's take a look at at least one example of each of the other rules that we have talked about with numbers today, but do it with letters. Um, in our third example, we're going to have a multiplying problem. So in a multiplying problem, you kind of have to regroup your problem because that'll give away what rules you're using. What are these numbers in front of letters called again? No, that was exponentials. Coefficients. Coefficients are numbers in front of letters. The x is the base, y'all. And negative 2 is your exponent. But this negative 3 over here is a coefficient. So we can put our coefficients in a multiplying problem. We can put our x's in a multiplying problem. And we can put our y's in a multiplying problem. So we can focus on one thing at a time. And that's what you need to do. You need to regroup the problem to put things that are called the same thing together. So I had two coefficients. And guess what? It says times them. And I don't move that 3 and get rid of that negative because that's not an exponent. I just do the math. That's negative 6. Now, this has a negative exponent. Where do you put negative exponents? On the bottom. You could. It's the same. Yes, it is. The only problem with that once in a while you run into is you still end up moving it because it comes out negative. But you can. Yeah, I could have added these two powers together to get that 3, or I can move it and subtract them and still get 3, but when I do it this way, I put it back on top because there's more on top than there is on bottom. With the other one, I have to know where to put it, but it still works. And then with the last one, I've got 4 and 9 are both positive, so I add them and get to the 13th. So if you had a tremendously large problem with lots of x's and lots of y's, then moving them might be important because you might have 3 or 4 to put together instead of just 2, which is not hard to add those two numbers. All right, let's look at a divide problem. It's originally written as a division problem. I'll leave it that way. Alright, let's look at this one. This is originally written as a division problem. It's kind of organized already. But some of the terms may need cleaning up. So I'm going to separate them and clean them up as we take them out of this big division problem. So I've got 36 to divide by 24. Does that divide evenly? What do you do in math if it doesn't divide evenly? No, because I don't have my adding. I want to divide something that don't divide evenly. Yeah, just reduce it down. Exactly. Simplify it. So 12 goes in both of those, and that'll be 3 over 2. So now I know my answer is going to be a fraction at least because I got 3 over 2 already. Then here on my x's, I want to get rid of that negative power and move it down. So now they're all on the bottom. How many x's are on the bottom? To go with the 12 I already had, 17. Because if you move the 5 down to go with the 12, you can see they're side by side. And when they're side by side, you add them. Which is why I wanted to move the negative down. Here's the other reason why I wanted to move the negative down. The rule in division is you subtract. Negative 5 minus 12 comes out negative. I like my positive powers. I don't like negative powers. So I always move them and get rid of the negative so I can work with positive powers. All right, what about this 0 power? Yeah, let's just throw it away. But there's a y to the second on the bottom that's got to come up and become a positive power. Do I have other y's to go with it if I threw that 0 power away? No. So that's just y to the second. And then I have z to the fifth and z to the seventh that aren't negative. So I just subtract them. And where am I going to put those two z's that I have left? On top, because there's more on top. So as the problems get more information to work with, it is best to simplify it by looking at one thing at a time. And then the last thing that we have hit on a little bit today, but we're going to hit on it with letters, and that is a power to a power problem. And as we look at this power to a power problem, we're also going to focus a little bit more on the fact that it can be fairly involved. Okay, so what's inside of my power problem is, it looks like a really large fraction. And I have a power on the outside, but what do I need to do? Start with it or start with the inside? Yeah, let's start with the inside. All right, so when we look at the inside, I've got 18 over 32. You think that'll reduce to what?
1 over 2. Oh, wait, no. 3 over
9 over 16? Because they divide by 2. And 9 over 16 won't go any further, right? Sometimes you just got to try a number. Start with the smallest one. If it needs to reduce it twice, reduce it twice sometimes. All right, now, I only have one of each letter, right? So I just need to make sure I put it in the right place. Where do these X's need to go? All right, where do the Y's need to go? Yeah, stay where they are because they're not negative. Z's, they're going to go up, are they not? Y, already on the bottom. Now, what do you do about the fact that there's a negative power outside? Yeah, we're going to completely switch the entire problem. Now, the last time we did that, there was a 1 on the outside. This time there's a 2 on the outside, so let's talk about that. That makes it a little bit more involved. So first, we switch everybody across the division line because they're to a negative power. And all that does is drop the negative off the power. Then you go back and you square everybody. You're going to say 16 squared, x to the 4th squared, over 9 squared, y squared squared, z to the 3rd squared. Now, how much of that you do on paper and how much you do in your head is up to you. But I'm going to tell you, a lot of times students miss this work because they're not focused on the right rule if they don't see it. So the number rule is you just square it. 16 squared is 256, I believe, if I remember correctly. 9 squared is 81. Numbers, you just square them. 16 times 16, 9 times 9. But what do you do when you have letters to a power to a power? You multiply them. And how I know that is anything against a parentheses is always multiplied. Think distributive. If you distribute something to everything in the math problem, doesn't that sound like you should be multiplying it? Well, that's what this looks like, doesn't it? It looks like distributive, a 2 on the outside of a parentheses. So that comes out to be x to the 8th, y to the what? And z to the 6. So this problem can be kind of involved, but when you get down to the end of the question, you don't have any negative powers, everything is completely reduced, and you can work out every part of the problem to a nice format. Alright, so today's lesson really just went back and reviewed a few things that you were supposed to know, but I added E, right? I added multiplying in some weird powers on the calculator, and we just did a lot of review on power rules that you're supposed to already know. Alright.